Let's see what is double cross ladder theorem and its proof. So here we are putting total 4 ladders, 2 ladders against one wall and 2 ladders against the second wall. The ladder's base is there at the base of one of the wall and inclined against the other wall. Now these ladders are crossing each other at these 4 points. Let's assume the height of these points as A, B, C and D. Now irrespective what is the length of the ladders and what height they are touching the wall and what is the length of alleyway, the double cross ladder theorem says that 1 upon A plus 1 upon D will always be equal to 1 upon B plus 1 upon C. For proof of double cross ladder theorem, we'll be using this single cross ladder theorem, the proof of which we have discussed in video number 38. So here, if two ladders are crossing each other, then the height at which they are crossing is given by this formula. That's 1 by h is equals to 1 by h1 plus 1 upon h2. So this particular formula we'll be using to derive our formula for double cross ladder theorem. Proof is very simple once you know cross ladder theorem. So before we start, let's assume the height at which the ladder is touching. This one is x and this one is w. Now these heights are not part of our double cross ladder formula, but they are used for the derivation purpose only. This height I'll assume it as z and this particular ladder height as y. Now if we'll take any two ladders, let's take this ladders first. So this yellow ladder and this another yellow ladder. They are inclined against the wall at height of x and y and they are crossing each other at height of a. Using our cross ladder theorem, so we know 1 upon a is equals to 1 upon x plus 1 upon y. So we are using here cross ladder theorem to get this observation. Same way, if we'll take other two ladders here, so these two yellow ladders, they are crossing at height of b. So this 1 upon b will be nothing but 1 upon w plus 1 upon y. So we are using again here cross ladder theorem to get this observation. Same way, if we'll take these two ladders, yellow ladders, one is this one and another is this ladder. So these are crossing each other at height of c. So we can say that 1 upon c is nothing but 1 upon z plus 1 upon x. And same way we'll go for these two ladders which are crossing at this point. So these yellow ladders, they are crossing each other at height of d. So cross ladder theorem, 1 upon d is equals to 1 upon w plus 1 upon z. Let's realign these observations and see if we'll add these two equations here on the left side. So what we'll get is LHS is 1 upon A plus 1 upon D and your RHS will be 1 upon X plus 1 upon Y plus 1 upon W plus 1 upon Z. Similarly, the second equation when we'll add LHS is 1 upon B plus 1 upon C and RHS is this what you are getting. If you will compare these two equations, right? So here you will find that the RHS is same, that's 1 upon W, X, Y and Z. Here also you have got 1 upon W, 1 upon X, 1 upon Y and 1 upon Z. So if RHS is same, then LHS will also be equal. And from here we are getting that 1 upon A plus 1 upon D. This is equals to 1 upon B plus 1 upon C. That A and D are the extremities of heights and B and C are the heights at the center points where the ladders are crossing. And this is what is your double cross ladder theorem. We'll be taking few questions on this to get its utility. I hope you have understood the theorem very well and we'll see you in next video. Till then, tata, bye bye.